I'm gonna get the bad news out of the way first, so the rest of this video can be fun. I'll be quick, I swear, put 30 seconds on the clock. Coral are bleaching and dying at an alarming rate due to pollution, warming oceans, and ocean acidification. We've lost about 50% of coral by area since the 1950s, and species extinctions are happening far faster than the natural rate. While it's a complicated subject, let me be clear. There is no doubt that human activity is largely to blame for these trends. But that's not news, and that's not what I want to talk about today. I'm going to talk with some of the people who are actually doing something about it, and I want to share some of the cool science that's going into their work to make it happen. So let's get started. Coral are neat little guys because they're not really one thing. They look like some weird cross between an animal, a rock, and a plant. And that's because that's exactly what they are. Coral is made of 3 parts, an animal, a rock, and a plant. The coral animal is a cnidarian, meaning it's related to sea anemones and jellyfish. The animal part is just the jelly-y bit on the outside. The coral animal builds up mineral and rock to form a skeleton for itself, and that ultimately forms the solid foundation of the entire reef. For the last part, tiny photosynthetic algae called zooxanthellae live inside the coral animal. They're only kind of plants, but what's important is that they photosynthesize, and that ends up providing energy to the coral animal. The zooxanthellae are what give coral their color, and they could give you 32 points in Scrabble even without a double word square. Coral can reproduce in a bunch of different ways, which gives restoration scientists a lot to work with. But most importantly, they can reproduce asexually, or they can reproduce sexually. Follow me. Asexual reproduction is awesome. It means that coral can reproduce without sex. There are several ways they can do this, but the most useful to restoration scientists is fragmentation. I talked with Shane Weaver from Reef Renewal USA about what that means.
So fragmentation is an asexual reproduction methodology used by corals. You can think of it a lot like propagating a plant. When you cut off a small chunk of the plant and you create that propagule that you'll stick into potting mix, we do the same thing with corals, except we cut off a little piece and we can stick it back on the reef.
Shane is the Restoration Program Director for the Upper Keys. Reef Renewal has been building out coral nurseries and replanting coral for about 5 years now.
Reef Renewal USA was started in 2019. Its focus is to make resilient corals for the future. Our goal is to outplant 100,000 corals a year.
But what does that work look like? Well, a lot of it is diving. They'll carefully break or saw off pieces of coral and then bring those to the nurseries. The nurseries are where the fragmented coral are grown, and Reef Renewal USA's workers or community volunteers will keep a close eye on them. Shane told me about 2 different types of nurseries that they use.
When we propagate our corals, we grow them on a couple different structures. We have PVC trees and we have verns, which are vertical rope nurseries.
The PVC trees are exactly what they sound like. They're tree-shaped structures made out of PVC piping. There are 2 types of these.
One is going to be hanging corals from these branches with fishing line. The other is going to have trays that are modular units that we can actually stick corals on, where we can organize corals on these little frag plugs.
But that's a more traditional approach. The vertical rope nurseries, or verns, are being used more commonly these days.
Vertical rope nurseries have become our standard for growing branching corals. Basically, you put some buoys on the top of a rope, and the bottom of the rope is going to be secured to the sea floor. That rope is kind of spun up, and when you unspin that rope, you can stick a fragment of coral inside of it.
What's really cool about these verns is that they move with the tides and the waves. That's also why they're often preferred over the trees. The PVC trees might break during a storm or rough waters, but the verns will move with the water and help buffer out that stress.
When hurricanes or storms come through, it doesn't smash them around, and it makes these verns a lot more resilient, and it also gives them a thinner profile, so they take up less space in our nursery, which means we can have more structures.
Coral restoration isn't easy work. There are lots of early mornings, long days of diving, and you're kind of fighting against the environment.
You have to rely on good weather. You have to rely on the ocean having good conditions, not just for the divers, but for the corals.
On top of the weather, there's also diseases, parasites, and...
Unfortunately, in 2023, we had one of the worst bleaching events that the Caribbean's ever seen.
Wait, what's a bleaching event? Remember the zooxanthellae, the algae that give coral its color? When coral get stressed, they'll get rid of their zooxanthellae, and that's bad.
So without it, they would look white. And so when you see coral bleaching, that is a coral that has, from some stress event, lost all of its symbiotic algae, and it's starving itself.
Yeah, not good. Coral bleaching won't immediately kill the coral, but it'll kill them pretty quickly if the stress continues. The 2023 marine heat wave in the Caribbean was really bad. Some coastal water temperature sensors reported water temperatures of up to 100 degrees Fahrenheit.
I think it was the worst that we've ever seen. And so years of restoration work was wiped out. Hundreds of thousands of corals that were stored in nurseries were gone.
It can be a tough job, with climate change seemingly working against you. But these guys don't give up.
But that didn't stop us. We pivoted, we made adjustments, we made changes. We were able to salvage some of those corals. In doing this, we have also been able to revolutionize some of our techniques to make our propagation more successful. We have a facility that used to create live rock, and they're now creating a gene bank of all of the corals that we can salvage out on the reef, but also turning into a propagation pipeline where they're generating hundreds and thousands of corals to then send down here to practitioners, so we can really boost the effort and the capacity that we have to restore the reef at scale.
Part of the problem with fragmentation is that the offspring don't have any genetic diversity. The new coral are clones of the old ones. You can expect them to perform about as well as the parent coral. The problem is, with the changing climate, the parent coral might not be doing so well.
The problem with this asexual reproduction method is all of the new individuals that are created are genetically identical.
That's Hannah Ditzler. She's on the research team for Seacor International.
Corals are quite fragile, so if a disease comes through, a stress event, etc., all of those corals can get wiped out because they're genetically the exact same.
Seacor is an organization that's taking a different approach. Seacor literally stands for Sexual Coral Reproduction, and that's exactly what they're doing.
This is a different approach because we're creating a lot more genetic diversity, and it has the potential to basically breed in qualities that we want the corals to have.
This method allows for genetic diversity, and that might give these young coral a better chance at surviving different stressful events. As a matter of fact, Seacor published a study just last year showing that their IVF-bred coral were far more resilient in the 2023 Caribbean marine heat wave. I asked Hannah to tell me the story of coming to these findings.
I think a lot of us during the 2023 mass bleaching event were really, really impacted by the state of the reefs. I know people were literally crying underwater watching these, giant palmata that have been around for, tens to hundreds of years, bleaching and reproducing. So we saw corals that were literally completely bleached, actually reproducing, and then pretty much dying. So it was really like an emotional experience for a lot of us, and it was really hard to see. But at the same time, we were seeing that basically corals right next to juvenile outplants that we had created were completely bleached and dying, and recruits that we had outplanted were actually fine. We kind of started seeing this data in Mexico and Curacao, which are our two other main office locations. And so we decided to investigate with our partners that are all over the Caribbean. We had people go out and collect as much data as they could on the different recruits that were out there and try and get good comparisons of adult colonies, parent colonies, or other close corals that were in the area, right? So we essentially found that the recruits were bleaching at a much lower rate than the adult colonies were, even within meters of each other. So colonies that were right next to each other that were juveniles were totally fine, and these adult colonies were bleached and hit really, really hard by the warm waters.
So how does this technique differ from using fragmentation? Well, fragmentation is pretty simple. You break off a piece, plant it, and wait for it to grow. Assisted sexual reproduction is a lot more complex, but let's break it down into 4 main phases: collection, larvae, attachment, and planting. Or clap.
Oh, thank you so much, thank you.
In the collection phase, scientists are monitoring the reef and can roughly predict when the coral will reproduce.
They basically release their gametes in a synchronous event based on full moon cycles and sunset times. So all corals of one species will essentially time their reproduction so that it happens at the same time. We are basically able to predict when certain species of coral are going to reproduce within an hour or two on a specific set of days.
These scientists will go out on the water in the middle of the night to monitor for the synchronous spawning event. And when it finally happens, they'll be there with nets and other equipment to collect the gametes.
We will bring collectors and basically place them over the coral. They look like a little tent made out of mesh, and they have weights on the bottom, so they sit on top of the coral, and then they have a little floating tube that sits on the top of them.
Once that's collected, we move on to the larvae phase. The gametes are mixed together and allowed to fertilize, and when the eggs hatch, the larvae are put back out in the ocean in what are called cribs.
Seacore uses cribs, which are coral rearing in situ basins. They are essentially these big blue floating pools that go in the ocean, and they allow for 500,000 larvae to be settled at a time.
After that, it's more waiting and monitoring development. Part of what they're looking at is the fertilization rate.
Sometimes we can actually get fertilization rates of near 100%, which is great, and that's not something that would necessarily happen in the wild.
When the larvae get old enough, they turn into planulae. During this phase of their development, they start looking for a place to settle, bringing us to the attachment phase.
They basically start swimming around in circles on the surface of the water, and then right when they're ready to settle, they will swim down to the bottom of whatever container they're in.
The planulae are looking for a hard surface to attach to. At this point, they're still in captivity, but they'll settle on a substrate and start growing into the animal rock plant combo that we all know and love. After more waiting and monitoring, these new recruits will be ready to outplant.
Once they settle, we're able to check their development and their growth, and then either outplant them or keep them in captivity to rear until we decide to outplant them.
This technique does come with its own unique challenges and drawbacks.
I mean, asexual propagation is much simpler. You're taking a coral, you're cutting it up, and you have two corals. And it produces a lot more biomass a lot more quickly than sexual reproduction ever will. So that's super important. You know, fish won't hang out on a reef that doesn't have any coral biomass. Sexual reproduction, it's definitely not an easy way of doing things, but it is kind of the only option, especially when we're, losing genetic diversity on reefs at such an alarming rate. It's a much more lengthy process, it's a lot more technical, and a lot more difficult, and requires huge amounts of man hours and a lot of technical knowledge on how to do it. And so while we are able to produce a lot of corals, they take a long time to grow to reproductive capacity and to have any real impact on a reef.
So in summary, asexual reproduction is simple and well proven. It can be done at scale and it restores biomass quickly. But all the new coral are clones. Sexual reproduction is complicated and takes a long time, but it can also be done at scale, and it's able to restore genetic diversity. So what does the future look like? Well, there is a lot to be concerned about, but there is a lot of hope. We're still losing coral, but the rate has significantly slowed down over the last 20 years. We also got some really good news in 2021, when we saw these IVF-bred coral reproduce for the first time on their own in the wild.
Curacao was actually able to see one of their earliest rounds of recruits reproduce. This basically shows that we're able to close the loop of sexual reproduction with the work that we're doing. That's hugely important. That's really the goal of all of this work, is to restore reefs to a point where they're able to do it themselves and we don't really need to be involved.
With all the good and the bad, how do our experts feel about the fate of coral?
I think they've seen so much devastation in the last 50 years. But we don't know how much devastation they faced in the 100 or 200 years before that.
Yeah, that's a tough question. I think that it kind of depends on what's going on. We are doing the work that we're doing now because the reefs are so degraded that in some places there are not enough parent colonies to successfully reproduce.
The coral reefs of tomorrow aren't going to look like the coral reefs of today or the coral reefs of my grandparents. As a community locally, we need to look ourselves in the face and figure out how we can make our marine environments healthier. And as an entire country, and even farther as an entire world, we need to really look in the mirror and say, do we really want to be doing this to the food that we're eating, to the places that we're swimming, to the place that regulates our climate, honestly?
But I do have hope that we can do it, otherwise I wouldn't be doing this. And there are reefs out there still that are incredibly beautiful and healthy.
I can't be helpless, right? I have to be hopeful because hope is all I got right now. And as long as there's still one coral out on the reef, I'm gonna keep on working as hard as I can to keep that coral healthy.
So I think there is a lot of hope out there as well, and we're really learning a lot. So I have hope that, we can figure this out. It's not going to be easy, and we need to continue to get funding. We need to continue having people dedicated to doing this, and we need to address the concerns of climate change. Ultimately, coral reefs are not going to continue to exist if we don't get a handle on climate change and make sure that our oceans don't warm to 100 degrees like they did here in the Florida Keys 2 years ago.
Community engagement is going to be the most important thing. We have partnerships throughout the community, working with dive shops, recreational divers, and volunteers in so many capacities to really get the community as a whole to be a steward for the ocean, but more awareness and more engagement and teaching the people that you love and the people around you about coral reefs is free and is one of the most impactful things. Letting them fall in love with coral reefs is going to be my best bet to making everybody else care about coral reefs the same way I do. I can't help but have hope for coral reefs.
It's, you gotta keep going. Gotta keep going.
So the future depends on us. It depends on you. We need to be funding science. If governments won't do it, we need to be helping with volunteering and fundraising. Shane talked about community building, getting your local community to care about the local environment and to care for it. But also, governments do need to be doing it. Contact your representatives and make sure they support funding science foundations. I'm gonna leave a link to 5calls.org in the description below. They make it really easy to contact your representative about specific issues. There's so much work being done, and like Shane and Hannah said, we really need to keep it going. I'm really excited to see what we can do together moving forward. If you'd like to learn more or get involved, there are plenty of organizations in the US to donate to or volunteer with. You can be the one to go out on the reefs, dive, and plant new coral. That's so freaking cool. I'll link a few of these organizations in the description below.
Thank you so much for watching. I had a blast working on this video and getting to talk with these experts who are clearly so passionate about what they do. Huge thank you to the teams at Seacor, Reef Renewal USA, and the Tennessee Aquarium for being so generous with their time. If you'd like to see more of this, you can support me in all the usual ways, like, comment, subscribe, or you can join my brand new Patreon. I'm launching my Patreon with this video, which can get you early access to videos, look behind the scenes, and occasionally blog posts about just my video creation process and what I'm working on at the time. Contributions start at $1 a month, and every little bit really does help. But that's enough of a sales pitch. The link for that is below, along with links to the full transcript and bibliography. Thank you again so much for watching, and I'll see you in the next one.